All right, this is another example. It's written out as a word problem. It says a dime has thickness 1.35 millimeters and a penny has a thickness of 1.52 millimeters. If you've got a stack of p pennies and d dimes, the linear transformation below gives the value in cents and the height in millimeters of the stack. And so that's given to us, right? And here's this function. And I've got three different things here to do. First, use s to determine the number, the value of a stack of 14 pennies and 10 dimes, and the value and height. All right, so this is all we have to do here is take S of 14 pennies and 9 dimes. So that's going to be, let's see, P is 14 plus 10 times 9, and 1.52 times 14 plus 1.35 times 9. And let's see, what is that? This first one is 90 plus 14 is 104. And the next one, 1.52 times 14 plus 1.35 times 9 gives me 33.43. And let's see, this is in cents and this is in millimeters. So 104 cents, 33.43 millimeters. Nothing really much going on there. Second one says find the inverse and write it out in the same form as S is given in above. So in other words, find the inverse of this linear transformation and then write it back out in this form. All right, so S inverse. Well, let's see, S has the matrix. Let's call it A. And that's going to be 110, then 1.52, 1.35. So the inverse of this thing is going to be okay, so the inverse is that. It's not surprising that we've got an ugly denominator there. I guess there's not really a good way. Well, I could factor out the 1385, but I'm just going to write it like this. Negative 27 over 277, 200 over 277, then 152 over 1385, and then negative 20 over 277. All right. Okay, so that's our inverse matrix. And if we want to write this out as an inverse linear transformation, I'm just going to call this x and y here, because it doesn't make sense to call this d and p here, because what we're putting in for this will be like a height and a value. So our inverse is going to give us negative 27 over 277x plus 200 over 277y, comma, 152 over 1385 x minus 20 over 277y. All right. And I wrote that incorrectly. This would be S inverse of x, y equals that. All right. And the last part of the question says, a stack of pennies and dimes is that high and worth $1.11. Use S inverse to determine the number of pennies and dimes. Okay, so the way we do this is we do S inverse of, let's see, which of these is first and which is second? Well, we'll go back up here and look. This gave us cents first and then height. So this is cents and height. So I'm going to plug in the cents first. It's $1.11, so that's 111 cents. And then it's 44.07 millimeters. So we've got to plug that into the function above. This doesn't look fun. Let's see, minus 27 over 277 times 111 plus 200 over 277 times 44.07 . And then let's see, 152 over 1385 times 111 minus 20 over 277 times 44.07. All right, so this is supposed to give us the number of pennies and dimes. Let's see. I'm just going to do this on my calculator here. Let's see, negative 27 over 277 times 111 plus 200 over 277 times 44.07. And now the moment of truth, I'm going to press the enter key and hope that this gives me a whole number. Sure enough, it gives me 21. All right, and for the other one, 152 over 1385 times 111 minus 20 over 277 times 44.07 gives me 9. All right, so that gives us that. So that's 21 pennies and 9 dimes. So what would the value of that be? Well, 9 dimes would be 90 cents plus another 21 cents, so $1.11. So this does work, even though this is kind of a dumb application. I can say that because I wrote the question, but it's actually using the idea of a linear transformation, and so it is an application of that. Although the problem this simple, you'd probably just work it out, some other way. But anyway, that's it. Example 304 is practically the same question, except it's dealing with carbon and hydrogen. I'm not going to work it. It's essentially the same problem. So let's see. Do we have anything else in this part? No. All right. Well, that's it for this part of the lesson.